Welcome to Weather Lab 12, Part 3. I had to cut Part 2 short because of timing, had to run off to a class, and I want to make sure that I completed the video so I don't lose it. So question for chapter 12, or Lab 12, we're going to start with questions 12, 13, 14, and question 11. Question 11, you're just labeling where the continental, Pacific, and the polar and the different fronts. So you're going to do a continental polar, a continental tropical, and a maritime tropical air mass based on the page on page 140. For questions 12, 13, 14, they're asking you questions about the weather stations on the map. So they're asking you to go to the weather stations on the previous pages, the ones you had to flick by, and pick one of the weather stations. They're being shown on the map above in figure 12-5, and they're just showing you different ones. But here is the Paris station, so if you want to use them, they're right here. And the conditions in Indianapolis are right here, and Indianapolis is right here. So pick one of these stations, and you're just going to tell me information about it. It's asking you for the temperature, the dew point, and the wind direction. Question 13 asks you how are the surface conditions of these places. And 14 asks you to compare the temperature and the dew point between the two dates. So just pick two stations and then answer 12, 13, and 14 on the two stations that you picked. So you're just writing sentences about those comparatives. Which brings us to question 15 and 16 and 17 and so on. So in question 15, they now introduce you to thunderstorms, and they give you these figures on the previous page, like 12-10 and 12-11, and they're showing you little dots, and the little dots are where the tornadoes occurred. Notice that they're in front of the cold front, and that's because the thunderstorm cloud is produced in front of the cold front, and the thunderstorm clouds are the ones that are capable of creating a potential cold front. And those can make tornadoes. Those can create the tornado ability. They also, in both of these cases, are squall lines. So they're an entire cold front that made a whole line of thunderstorms, and those lines of thunderstorms can go on to be strong enough to make a tornado. So for question 15, what is similar about where the tornadoes occur relative to the surface weather patterns on the June 2nd and 3rd, and on the February 5th and 6th, well, I've kind of just answered that. They're in front of the cold front. So it's not about the state location, it's about the weather condition. And they're in front of the cold front, and they're along what would be a squall line, because it's forming in front of a front. So that's the answer to question 15. So that brings us to how to read another form of showing weather maps, and these are the weather stations themselves being shown at multiple altitudes. Question 16 asks you to look at the June 2nd, 1990 map for the little town that Padua? It's not Padua, it's Padua, I think. I'm not sure how to pronounce the town. And they're asking you to locate the inversion. Now the inversion, as a reminder, is the point where the air, instead of cooling off like it should, will inverse and warm up. And you got to look really careful. It's going to be in the lower parts of the altitudes. And they ask you to just circle its location. And it's right here. So there you go. Question 16 answered. So that brings us to 17. How would you characterize the temperature and moisture of air between the surface and the 700 millibars at the location of this little town? So we're going to look at the 750 millibar line. That's about here, right? If I'm looking, 750 millibars of pressure. And that's going to be somewhere about there, right? I'm going to draw a little line. And you're going to compare what's going on between its temperature and its dew point, that's what they mean by moisture, between these two locations. So you're going to take the surface down here and read its temperature and its moisture readings, and you're just reading them off the bottom here. And then you do the same thing here. You take its temperature and its moisture readings. and you write them down. Ta-da! 18. How would you characterize the temperature and moisture of air above at the 500 millibar line in the same community? So we're here, 500 millibars, same thing, except the dew point went way, way down. So it's over here, and the temperature is here, right? So you're going to put all that information in and just write it down. So question 19 asks you to use the wind speed direction symbols in figure 1213 as guides to draw wind speed direction symbols at the 250, 500, 700, 850, 925 millibars for figure 1214 and 1215. What they're talking about is these symbols on the side here that I'm highlighting. And the way that they're drawn is they're drawn on a compass. So that little image of the circle above is a compass, and they're trying to give you a feeling for how you would draw it. So for example, if the air mass, this is my north, my south, my east, and my west, if my air mass was coming from the east, I would draw it sticking its tail out over here. And then I would do its knots based on its wind speed. So if it was 50 knots, I would draw my flag at the end. If it was 10, I would draw my single long line at the very end of the tail. And if it's 5 is never drawn at the end of the tail. The half bar to identify it is always drawn just slightly off center of the bottom like that. So that would be my 5 knots. I'm going to put it all together. As far as where I get my wind speed, I get them from the table above. Right here in the table, they give me Little Rock and Topeka, and they tell me the wind direction based on a compass, so going 360 degrees, and they give me the wind speed. So for example, in Little Rock at the 200 millibar line, for my set, because my millibars are over here, right? They're telling me the height. So this whole line is 250 for each location. So at my 250 millibar line, my wind direction is a set of 260, and my wind speed is 58 knots. Now that we have to round, so we're going to round to 55 knots. And I want to go to the 260. So you just think of your standard compass. 260 degrees is not quite west, it's just slightly less than west. So I'm going to draw it kind of like this. That'll be my line bar. And then I'm going to draw my wind speed. And for that I'll do a flag for my 50. And I will do a little half bar for my 5 because I'm rounding to 55. My next location will be at the height of 500 millibars, and I know for that I'm at 215 degrees for my tail, and my wind speed will be 70. So if I'm going 215, that's not quite to 270, and it's not 180, so it's kind of sticking down like that. And I want to do a 50 line, a 60 line, and a 70 line. So that's my wind speed for that. So now that you got a feel for what you're doing, complete the wind tails for all of the 2 locations, both Little Rock and Topeka, and for both my remaining altitudes of 700, 850, and 925, and then all for Topeka on the Topeka map on page 147. And I'm going to end this part 3 here, and I'm going to actually pick up with question 20 and work my way through to question 25 with you guys in a part 4, because they'll have to go back to the standard US size maps with wind speed and wind direction. We'll just be at different millibars of pressure.